We're absolutely delighted to have opened the QUEST lab. This is quantum engineering using solid-state technologies. And really it represents a dramatic change in the capabilities that we have for the fabrication of quantum devices and testing and characterizing them at cryogenic temperatures. And we think that these facilities are going to be really fundamental to start taking these technologies out of the laboratory and producing really useful devices.
The QUEST labs are all about solid-state quantum technologies. There are lots of different kinds of platforms for quantum tech being studied nowadays. Some of them are very well isolated, individual atoms, individual ions, but there are massive advantages to using objects that are solid objects, if you like. They're lumps of stuff, they just happen to be small stuff. QUEST labs will enable us to make these things, to study them, and to apply them to a whole range of different quantum technologies.
It really puts us on the map as the place to come for research in solid-state quantum technologies. And it's very exciting to think of the progress that will be made here using the equipment in the QUEST laboratories.
We now have a fantastic resource for getting to the very low temperatures, around about 10 millikelvin, we need to conduct our experiments. Not only that, but of course have the high-frequency, low-noise electronics for running our experiments once we obtain these temperatures.
It's a fantastic opportunity for our students because this is an industry that's emerging, remember, and we are very conscious that we're training our students not just to be academics in this field, but to be the founding entrepreneurs and chief scientists of this new industry. It's really giving them a hands-on experience of what the tools of this transformative technology are going to be.
I think that a very important milestone which we will cross between now and 2030 is sometimes called quantum computational supremacy, where a quantum computer has been demonstrated to be able to achieve some sort of computation which is beyond the capabilities of even the most powerful conventional computer. And that includes, even the largest supercomputers built on conventional classical computing technology.
Recent government announcements have been very encouraging in showing that the government is still committed and will continue to fund the ongoing program over the next 5 years. It was great to see Jeremy Wright here from the Department of Digital Culture, Media and Sport, really as a representative of that governmental commitment. And I think very much at the moment, quantum computation is at the pre-competitive stage, and it does rely upon support from the public sector to kickstart this really important area and to make sure we don't fall behind other nations, each of whom has major programs in quantum technology, notably the US and China, other European Union countries, of course.
Basing QUEST within UCL, we're both located right in the heart of one of the most vibrant quantum science and technology research environments in the UK. But we also benefit from our position in London that's connected to a range of other universities within London and in the immediate area, both academic and commercial institutions. I would say that location and the local environment that we have in UCL in particular makes this the perfect place for QUEST.